Okay, this is Chapter 11, Section 3, Expected Value, which is commonly called expectation. It says, why is this important? Expectation is used throughout the financial services industry and especially the insurance industry to set rates for products and services. Expectation is used by manufacturers when determining the length of the warranty on their products. Expectation is also used by many businesses whenever difficult decisions must be made. Expectation provides a tool that can be used to analyze all possible outcomes of a decision. The definition for expected value or expectation is expected value, also called expectation, is often used to determine the expected results of the experiment or business venture over the long term. Common formula is where you take the probability of a certain amount times the probability of the second amount probability. It's easier, the formula is kind of hard to understand. It's easier to look at an example. This one says, this is example 1 on page 668. It says, Spirit Airlines is considering adding a route from Pittsburgh to Nashville. Before making a decision, the company needs to consider many factors, including potential profit and loss. After considering considerable research, Spirit estimates that if it adds the route, there's a 60% chance that of making an annual $800,000 profit, a 10% chance breaking even, meaning zero profit, and 30% chance of losing $1 million. How much can Spirit expect to make annually on this route? Well, here's what happens. So it's a 60% chance of $800,000. So we take 60%, turn it to a decimal point, 6, and multiply times 800,000. Plus, we have a 10% chance of breaking even, so 0.1 times 0. Plus, we have a 30% chance of losing $1 million, so 0.3 times negative 1 million. See, if we lose, it becomes a negative number. If we do this math, we get $180,000. So Spirit can expect to make at least $180,000 profit if they go into this venture. Here's another example problem, test-taking strategy. It says Maria is taking a multiple-choice exam in which there are 5 possible answers for each question. The instructions indicate that she will be awarded 2 points for each correct response, that she will lose a half point for each incorrect response, and that no points will be added or subtracted for answers left blank. If Maria does not know the correct answer to a question, is it to her advantage or disadvantage to guess at the answer? Okay, so in part A, we have 5 possible choices. So there's only one correct answer, so your probability is 1 over 5. The other 4 are incorrect, so your probability of guessing incorrectly is 4 over 5. If we take and go 1/5 times 2, because she gets 2 points for correct answer, 4/5 times negative 1/2, and do the math, we get 0. Thus, Maria's expectation is 0 when she guesses. Therefore, over the long run, she will neither gain nor lose points by guessing. Part B says if she can eliminate one of the possible choices, is it to her advantage or disadvantage to guess an answer? So what happens now is this is going to remain the same, but this is going to change, because this is now going to be 3 out of 4, because she can eliminate one of the choices, so we can eliminate a number from top and bottom. So what happens now is we do the math and we find out she's a positive 1/8. So since the expectation is positive, Maria will, on average, gain 1/8 of a point each time she guesses. Okay. Come over here. Here's another example problem. I'm not going over all example problems, so just some I think you ought to look at. Winning a door prize. It says when Josh attends a charity event, he is given a free ticket for the $50 door prize. A total of 100 tickets will be given out. Determine his expectation of winning the door prize. So winning $50 is 1 out of 100. There's only one prize. Not winning anything is 99 out of 100. So in terms of this, his expectation is 50 cents. Thus, Josh's expectation is 50 cents. Okay? Come over here, raffle tickets. All right? This one says 1,000 raffle tickets are sold for $1 each. One grand prize of $500 and 2 consolation prizes of $100 will be awarded. The tickets are placed in a bin. The winning tickets will be selected from the bin, assuming that the probability that any given ticket selected for the grand prize is 1 over 1,000, and the probability that any given ticket selected for a consolation prize is 2 over 1,000. Determine Irene's expectation if she purchases 1 ticket and if she purchases 5. So purchasing one ticket just goes 1 out of 1,000, $4.99, and you got to take the dollar away because you paid $1 for the ticket. 2 over 1,000, $99. You got to take $1 away from the 100, make it 99. That's the reason the 500 becomes $4.99 and the 99 becomes 100. Okay, so there's 3 possible prizes. Take it away from 100 tickets. That means from 1,000 tickets, that means 997 tickets are going to have a negative. They're going to lose their dollar. If we do the math, we find out we got a negative 30. If we do the 5 tickets, then what happens here is, on average, Irene loses $3.30 on each ticket purchase. So if you multiply that by 5, she loses $1.50. Next, we come to fair price. And what fair price is, the fair price is the amount to be paid that will result in an expected value of $0. And fair price is pretty easy. Fair price is just taking the expected value and subtracting the cost to play. So if we look at example 8, it says, in example 7, the cost of a raffle ticket was $1, and we determined that the expected value was negative 30 cents. That's the one we just got through doing. Determine the fair price of the raffle ticket. Well, we're going to take $1, subtract 30 cents from it, so the fair price is 70 cents. It says verify that the raffle ticket, if the raffle tickets were sold for the fair price, determine in part A the determine the expectation would be $0. So what would happen here is we'd come over here and we would go 49, 99, 30, because remember, $500, but we're subtracting 70 cents, which is the expected value. 2 over 1,000, 99, 30, because we subtract 70 cents. And then there's the expected payout. There's going to be 997 people who lose their 70 cents. Do the math and we get a 0, so it works.